Hey class. So today we're going to be talking about 2.3, which covers the multiplication property of equality. So just as a reminder, what I want you guys to be doing is taking notes while I'm writing everything out. I'm going to start off by talking about definitions and the theory behind what we're going to be doing, and then we're going to jump into examples. And whenever you see an example, I want you to pause the video, try to solve the example yourself, and then play the video so that way you can see me solve it and see how you did. So without further ado, let's start with the multiplication property of equality. So it states that if A, B, and C are members of the reals, then A equals B and AC equal to BC are equivalent equations. Now, there is one disclaimer about this definition. Let me finish writing this first, equations. The one caveat to this is that, let me write this in red because it's a big point, C cannot equal 0. Why? Well, as you can see, if we just make A and B 4, well, that says 4 equals 4. And that's a good equation. But if we multiply both sides by 0, then we get 0 equals 0. And now we're not talking about the same thing, right? So the reason why we don't use zeros is because it just cancels everything out. And it's also going to play into the fact that when we talk about multiplication, we're also talking about division, right? Because if I say that A divided by B, right, this is the same thing as saying A times the reciprocal. So A times 1 over B, right? And just to make this clear, if I decide to say A divided by 1/2, that's going to be equal to A times the reciprocal of 1/2, which is 2. So this is 2A. And remember that we run into really sketchy problems when we have 0, because 0 doesn't have a reciprocal. So we don't want to be dividing by 0, and we don't want to be canceling everything out. So C is just not going to be 0. But anything other than C that's in the real numbers, we can multiply or divide both sides of the equation in order to get an equivalent equation. And remember that the reason why we want equivalent equations is because equivalent equations give us the same solutions. Okay, so now let's jump into examples. Okay, so here are our first two examples. And again, I want you to pause the video, try to solve these on your own, and then unpause the video once you're done, so that way you can see the solutions. Now, let's get into how to solve example 1. So if we look at this, whenever we're trying to find a solution, we want to have the variable on its own on one side of the equation. Doesn't matter which side, we just want it on one side of the equation alone. So, how do we get rid of this 5 over 2? Well, when we were adding and subtracting, we tried to cancel it out and get 0. But now, since 5 over 2 is multiplying x, we don't want to get it to 0, we want to get it to 1. So what we do when we have a fraction in front of our variable is we multiply both sides by the reciprocal of that fraction. So if we multiply both sides by 2 over 5, that's 5 over 2x, that equals to 15 times 2 over 5. Now we see that 5 here cancels out, 2 there cancels out, and then we're left with x is equal to 15 times 2 over 5. Now again, we can cancel things out. So 15 divided by 5 is 3. 3 times 2 is 6. So our solution to this is x is equal to 6. Okay, So now let's look at our next example. Again, we have something on the left-hand side multiplying our x, and we want to get rid of that. So how do we get rid of a -3? Well, we want to get it to 1. So to get a positive number to 1, you just multiply the reciprocal by the reciprocal. But now we have to deal with the negative sign as well. So we have to multiply by the reciprocal and make that reciprocal negative. So if we look at -3x, we're going to multiply it by -1/3. So we have -1/3 times 3x times -3x, and then we have 33 times -1/3. Okay. Doing the canceling, this becomes positive, positive. So we're left with x on the left-hand side, and on the right-hand side, this negative does not cancel out, but when we have 33 divided by 3, the 3's do cancel out, and we are left with, this cancels to 11, this cancels to 1, and our solution is x equal to -11. Okay, let's look at some more examples. And here we have 2 more examples. So in example 3, we're dealing with decimals, and in example 4, we're dealing with a combination of what we did last section and what we're doing in this section. So go ahead, pause the video, try to work these out on your own, and then I'll go ahead and show the solutions. Okay, so in the left-hand side, don't be afraid by decimal places. So we do the exact same thing. Excuse me. We do the exact same thing. When we want to get rid of this 2.5, we just multiply both sides by 1/2.5. 5x. And then on the right-hand side, we have 5.0 times 1/2.5. I don't want you to confuse that for a negative sign, so I'm going to erase. Okay, that was a big erase. 1. Okay, 1 divided by 2.5. There we go. Okay, close enough. Whatever. So when we do this, the 2.5's cancel out. We're left with x on the left-hand side, and on the right-hand side, 5 divided by 2.5 is 2. On the right-hand side, we are going to be dealing again with stuff that we did last section. So the first step when you're dealing with these kinds of problems is typically you want to move the like terms together first. So you always want to try to simplify by adding all the like terms or combining all the like terms. So in this example, we're going to add 4 to both sides of the equation. When we do that, we're going to get -z on the left-hand side, and that's going to be equal to 6 plus 4. So -z is equal to 10. And then we have to get rid of this negative sign. So think of remember when we see just -z, that coefficient is just -1. And the reciprocal of -1 is -1. So we're going to multiply both sides by a -1 times -z. And that's going to equal 10 times the -1. So we get our solution of z is equal to 10. Oh, sorry, -10. Z is equal to -10. Okay, so let's look at 1 or 2 more examples, and that'll be it for today's video. Here we have our last example. So here we see that on the left-hand side, we're going to have to follow the rules of PEMDAS and distribute first. While on the right-hand side, we're just going to combine like terms. So let's go ahead and do that. 5 times 2x is going to be 10x. 5 times 3 is going to be 15, so we have 10x plus 15 on the left side. And combining like terms, 7 minus 1, or rather -1 plus 7, is going to be 6. So then, again, we want to keep with the combining like terms, so we're going to subtract 15 on both sides. When we do that, we're left with 10x on the left-hand side, and then 6 minus 15 on the right-hand side, which is going to combine to be negative 9. So now we have 10x is equal to negative 9. And we want to get rid of this 10, so we multiply by the reciprocal, 1 over 10, 1 over 10. And we get our solution of x is equal to negative 9 over 10. Okay, so there is one more thing I want to talk about before I end this video. It's a topic that they bring up in this section. So let me just erase this really quickly. So the topic is about consecutive integers. Consecutive integers. So consecutive integers are integers that follow one another consecutively in order. So 1, 2, 3, those are consecutive integers. And we can talk about problems with consecutive integers and try to write an algebraic expression for consecutive integers. So if we wanted to write 3 consecutive integers in terms of x, what that would look like is we would have x plus 1 plus x plus 2 plus, and we could keep this going, right? So let's say we wanted to know the sum of 3 consecutive integers. So what is the sum of 3 consecutive integers? Well, the first integer is just going to be some number x. And then the next integer that's consecutive is going to be x plus 1. And then the third consecutive integer is going to be x plus 2. When we combine these like terms, we're going to get 3x plus 3. And this is a relationship that is true for all integers x. So if we wanted to ask what the sum of 1 plus 2 plus 3 was, we could use this, right? 1 plus 2 plus 3 is 6. 3 times 1 is 3, plus 3 is 6. So it works out for the first 3 integers. And it turns out no matter which 3 consecutive integers you try to add, you will always get 3x plus 6. Now with this, we can also define how to write consecutive even integers and expressing their sum. All we are going to do is replace this 1 with a 2, and then this 2 with a 4, and so on. So that is going to be the end of this video. I hope this helps you guys, and I'll see you next time.